Hi everyone, this video lesson is for ratios and ratio tables, Chapter 5, Lesson 1. Our learning target is to be able to understand ratios of rational numbers and use ratio tables to represent equivalent ratios. To be able to do that, our success criteria says that I can write and interpret ratios involving rational numbers. I can use various operations to create tables of equivalent ratios, and I can use ratio tables to solve ratio problems. Our vocabulary is ratio, value of a ratio, equivalent ratio, and ratio table. Our key idea is ratios. A ratio is a comparison of two quantities. The value of the ratio A to B is the number A over B, like as a fraction, which describes the multiplicative relationship between the quantities in the ratio. 2 snails to 6 fish. That could be written 2 to 6, or 2 over 6, or 2 to 6. 1/2 cup of milk for every 1/4 cup of cream. That could be written as 1/2 to 1/4. Or we probably wouldn't write this as a complex fraction, but we could write it as 1/2 to 1/4. The ratio of A to B can be written as A colon B, just as I've showed, right here and right here. So it says, example 1, writing and interpreting ratios. You make flubber using the ingredients shown. Here's your ingredients over to the left. Write a ratio of cold water to glue. So here's cold water and there's glue. So we could write it a couple ways. 3/2 over 2, that would be like a complex fraction. We could write it as 3/2 colon 2, or we could write it as 3/2 to 2. B says find the unit rate of the ratio. So in that situation, we're going to want to use the complex fraction. 3/2 divided by 2 is the same as 3/2 multiplied by the reciprocal, which is 1/2. So we get 3/4. In this example, write a ratio comparing cups of water to cups of barbecue sauce used in a recipe. So we could write this as 2 over 5, 2 to 5, or 2, and then the word 2, 5. And then to find the unit rate of the ratio, two-fifths. This would be long division. 2 divided by 5. Because unit rate means we need to get the denominator to be per 1. So we divide by 5. We divide the top by 5. And so that's why we do long division. 5 doesn't go into 2, but 5 goes into 24 times with no leftovers. So the unit rate is 0.4 to 1. Now you try it. You mix 2/3 teaspoons of baking soda with 3 teaspoons of salt. Find the unit rate of the ratio. So let's write this one as a complex fraction. 2/3 over 3. That is really just 2/3 divided by 3. And we know that is really 2/3 times the reciprocal, which is 1 over 3. 2 times 1 is 2, and 3 times 3 is 9. So 2/9 or we could write it as 2 to 9 or 2:9. Two ratios that describe the same relationship are equivalent ratios. The values of equivalent ratios are equivalent, and you can find and organize equivalent ratios in a ratio table by adding or subtracting quantities in equivalent ratios, or by multiplying or dividing each quantity in a ratio by the same number. In example 2, it says completing a ratio table. Find the missing values in the ratio table, then write the equivalent ratio. So let's think about how we would get from 3 to 12. We'd multiply by 4. So we need to do the same thing down below. 3/4 times 4. 3 times 4 is 12, and 4 times 1 is 4. 12 over 4 is 3. So then how would we get from 3 to 15? We'd multiply by 5. So there we need to do 3/4 times 5. That's going to give us 15/4, or we could say 3 3/4, however we want to say it. Okay, so that's 15/4. And then we need to find this last spot. I think the easiest thing to do here would be think about how do I get from 5/4 to 15/4. I multiplied by 3. So to get from this to there, I need to times by 3. So what number times 3 is 15? It's 5. So all we're doing here is we're applying factors. We're doing equivalent fractions by multiplying or dividing the top and bottom by the same value in order to write new fractions, but the bottom line is these are all equivalent. In this example, it says create a ratio table to show how much a tree grows each year over a 5-year period if the tree grows 18 inches each year. So let's say we have the height of the tree and years. At 0 years, the height is 0 inches. At 1 year, the height is 18 inches. Now you could continue this table several different ways. You could multiply both sides by 2, and you'd get 2 and 36. You could continue this, and you could multiply both sides by 3. 1 times 3 is 3. 18 times 3 is 54. But now you could also just add a year. So you could add 1 year, and then for every year we add, we would add 18 inches. So 54 plus 18 is 72. If we add another year, then that means we add 18 more inches, and that puts us at 90. Now I want to show you though, it's the same thing. If we go back up to our first year, 1 times 5 is 5. 18 times 5 is 90. So you can do these ratio tables multiple different ways. Now it's your turn. You try completing the ratio tables to find the missing values and push play when you're ready. Well, for this first one, I noticed right away, I'm going to have to multiply 4 by 4 to get 16. So I'm going to have to multiply 5 halves times 4 as well. I can cross simplify, and I get 10 over 1, or 10. Now that helps me, because now I can see to get from 10 to 5, I'm going to divide by 2. Make sure you're going the same direction. I went left to right, so 16 divided by 2 is 8. On for number 3, 0.4 times 3 is 1.2, so I'm going to multiply 0.75 times 3. And I get 2.25. And if I wanted to get from 0.4 to 1.6, there I'd have to multiply by 4. So 0.75 times 4 is 3. And here's 2 more for you to try. Find the missing values in the ratio tables, then write the equivalent ratios. In this one, I noticed that if I go 4, I can divide by 2, and I get 2. So 10 divided by 2 is 5. Now for me, that was a really important first step, because now I have 5 and 15, and those numbers are compatible. 5 times 3 is 15, so 2 times 3 gives me 6. Last, I have this 8, so I'm going to go 4 times 2. That puts me at 8. So then I'm going to do 10 times 2, and that puts me at 20. And then finally here I have feet and seconds. 6 times 2 is 12. So 1/3 times 2 is 2/3. I need to find this missing value next. I'm going to do 1/3 times 3 is 1. So 6 times 3 is 18. And then for me, I think the 12 to 24 is going to be an easy one. 12 times 2 is 24. So 2/3 times 2 will give me this last value. So 4/3. So now we have some story problems. Writing and interpreting ratios. You include 1/2 tablespoon of essential oil in a solution for every 12 tablespoons of jojoba oil. Find and interpret the value of the ratio of jojoba oil to essential oils. So here we are essentially looking for unit rate. How much essential oil per tablespoon of jojoba oil? So we could do this 2 different ways. Here's our first way. We could just set it up as a ratio. 1/2 over 12, which is 1/2 divided by 12. 12 is 12 over 1, and we know that we can multiply by the reciprocal. and we get 1 over 24, or 1 to 24. So this tells us it's 24 times the amount of jojoba compared to the essential oil. Another thing you could do is make yourself a table. 1/2 to 12. Multiply that by 2. 1/2 times 2 is 1. 12 times 2 is 24. So there we can see, again, if this is essential oil and that's jojoba oil, we can see that we have clearly 24 times more jojoba oil compared to the essential oils. Okay, in this one we have all fractions. And for me, multiplying the fractions in my head, that can be a little bit tricky. For example here, we have to figure out what is 1/12. What could we multiply 1/12 by to get 2/3? So I'll go 1/12 times what equals 2/3? And I don't know. So what I want to do is I want to turn 2/3 into a fraction that's equivalent and has a denominator of 12. 3 times 4 is 12. 2 times 4 is 8. So now if I said that this is 8/12, well, that becomes really easy now. 1/12 times 8 is 8/12. And 3/2 times 8. If we cross simplify that, we get 12 over 1. Now to finish this one up, we'll go 3/2 times 7. 3 times 7 gives us our 21/2. And 1/12 times 7 gives us 7/12. In this example, we're modeling real life. You mix 1/2 cup of yellow paint for every 3/4 cups of blue paint to make 15 cups of green paint. How much yellow paint do you use? So let's make a bit of a table here. Yellow paint is going to be 1/2 of a cup. Blue paint is going to be 3/4 of a cup. So now when you add 1/2 plus 3/4, we'll find the total. We need common denominators, so 1/2 is going to be 2/4 plus 3/4 is 5/4, or 1 1/4. So now it says you mix and you want to get 15 cups of green. So this was 5/4. So let's continue our table then. If we take 5/4 and we multiply that times 4, 5/4 times 4 over 1 is 20/4, or 5. That's our total. Now let's do that again. This time we're going to multiply by 3, because 5 times 3 is 15. We want 15 cups of green paint. The question asks how much yellow paint. So now we need to apply the same factors over on this side. 1/2 times 4. So that's 4/2, which is 2. And then we multiplied by 3. 2 times 3 is 6. So when we have 15 total cups of green paint, that means we had 6 cups of yellow paint, means we must have had 9 cups of blue paint for our total of 15 cups of green. An engine runs on a mixture of 0.1 quarts of oil for every 3.5 quarts of gasoline. So let's make our table. Oil and gas. Oil is 0.1 quarts and gas is 3.5. You make a 3-quart mixture. How much oil and how much gas do you use? So this right now is 3.6. So we're going to use what you call scaling here. 3.6, let's divide that by 6. 3.6 divided by 6 is 0.6. And what we want to do is we want to get to 3. So from 0.6, we can multiply by 5. 0.6 times 5 is 3.0. So we kind of have created our roadmap or our rules. We're going to divide by 6, then multiply by 5. So now we just need to do that same thing for the oil and the gas. 0.1 divide by 6. Six doesn't go into 1, it goes into 10 once. 1 times 6 is 6. So we take away and bring down a 0. 6 goes into 40. 6 times 6 is 36. And that's going to repeat. 0.016. And now we need to multiply that times 5. So 0.016 times 5. 5 times 6 is 30. 5 times 1 is 5. And 3 more is 8. 5 times 0 is 0. So we get 0.08 quarts. Now we just need to do the same thing for gas. Or the smarter thing to do would be to just look here. We have 3 quarts. And we're going to take away 0.08. So 3.00 minus 0.08. We get 292. So 2.92 quarts of gas, 0.08 quarts of oil, and that gives us a 3-gallon mix. Finally, let's try it. A satellite orbits Earth, traveling 14.5 miles every 3 seconds. How far does the satellite travel in 3/4 of a minute? So we'll go a table here. We'll go miles and minutes. It goes 14.5. So we can say 14.5 miles for every 3 seconds. Okay, so I actually want to change that from minutes, and I want to say that's seconds. How far does the satellite travel in 3/4 of a minute? Okay, 3/4 of a minute. So that would be 3/4 times 60 seconds in 1 minute. So that's going to be 180 over 4. And 180 divided by 4 is 45. So 3/4 of a minute is 45 seconds. So that's what we want to get to. We want to get to 45 seconds. So we need to think about what we need to multiply by. 3 times 15 gets us to 45. So on the other side, we also need to multiply by 15. 14.5 times 15. 5 times 5 is 25. 5 times 4 is 20, and 2 more is 22. 5 times 1 is 5, and 2 more is 7. 0 for a placeholder. 1 times 5 is 5, 1 times 4 is 4, and 1 times 1 is 1. So we get 5, 7, 11, 2. And we have 1 digit after a decimal point. So 217.5 miles in 45 seconds.